Guys, so today we are going to be looking at proving conjectures using deductive reasoning. So we've been dealing with inductive reasoning so far. And in inductive reasoning, we make specific observations, find a pattern, and then use those specific observations and the pattern that we find to make a general conclusion. And deductive reasoning is kind of the opposite. So in deductive reasoning, we take general truths, use some logical reasoning, and then come to a specific conclusion. Okay, so in inductive, we go from like specific to general. In deductive, we go from like general to more specific. So deductive reasoning uses facts, definitions, accepted properties, and laws of logic to form a logical argument to draw a specific conclusion, and a proof is a mathematical argument showing that a statement is valid in all cases or that no counterexample exists. So we can't prove statements using inductive reasoning. Just because we haven't found a counterexample yet doesn't mean that one doesn't exist. So maybe you were checking, hundreds of numbers. Maybe the next one would have been your counterexample and you just didn't happen to check it. So inductive reasoning, there could always be a counterexample. So if we're trying to prove a statement, we need to use deductive reasoning. And we have two tools in our deductive reasoning toolkit that are very useful. So the Law of Syllogism and the Transitive Property. So remember, in deductive reasoning, we use facts, definitions, properties, and laws of logic to form logical arguments. And here are two of those tools. So here we have a law and we have a property. So this first one, the Law of Syllogism. So the Law of Syllogism starts out with two conditional statements here. So we have if hypothesis B, then conclusion Q, and then if hypothesis Q, then conclusion R. And we have to assume, or we have to know that these two statements are true. Okay, so these two things need to be true. If they are not, our logic is going to just break down and it will not work. So we will have a faulty proof, which we're going to be talking about next class. So if these two statements are true, then I can combine them into, so if hypothesis P, then conclusion R. It helps to sometimes write this like in mathematical symbols. So if A is B and B is C, then I can say that A is also C. Just give that a quick recolor. Okay, so an example of using this, you have done this before and you've probably done this all the time, but our first example is we're going to use deductive reasoning to make a conclusion from these statements. So all dogs are mammals, all mammals are vertebrates, Shaggy is a dog. Now we are going to see what can be deduced about Shaggy. Okay, so our first statement is all dogs are mammals. Yes, that is true. Okay, got it. Dogs are mammals. Great. All mammals are vertebrates. Great. That's also true. So all mammals are vertebrates. So we can deduce about Shaggy, who is a dog. So since Shaggy is a dog, and dogs are mammals and mammals are vertebrates, we can deduce that Shaggy is a vertebrate and that Shaggy is a mammal. So since Shaggy is a dog, I can deduce that Shaggy is a mammal and Shaggy is also a vertebrate. Now you'll notice that the arrows are going kind of one direction here. So yes, all dogs are mammals, but not all mammals are dogs. Same thing with all mammals are vertebrates, but not all vertebrates are mammals. So if I were to think about this like a Venn diagram, it would look like this, except not so hideous. So Shaggy would be in here. So Shaggy is also a mammal and also a vertebrate, but there are mammals that are not dogs. So for example, I could have a cat that is also a mammal, is also a vertebrate, but is not a dog. Okay. So the transitive property is our second tool in our deductive reasoning toolkit. And it states that if two things are equal to the same thing, then they are equal to each other. So symbolically, what that looks like is if A equals B and B equals C, then A also equals C. So it's very similar to our law of syllogism, except for it can go both ways. So A is equal to B and B is fully equal to A, whereas this guy right here only goes one way. So A leads to B, but B does not necessarily lead or go back to A, like it did in our first example there. Okay, so we're going to take a look at this. So for example 2, we're going to use deductive reasoning to prove the following conjecture. So the sum of two odd numbers and an even number is an even number. So in order to prove this, I can't just start taking two odd numbers and an even number, adding them together and seeing that I get an even number. Okay, so that would be using inductive reasoning, and then I would have to check literally the sum of all the numbers, all of them, infinite numbers. We can't do that. We don't have the time. Nobody wants to do this. So we're going to prove this using deductive reasoning. So for deductive reasoning, we can show that it's going to be true for all cases. So to show that it's going to be true for all cases, we're going to have to use variables and not examples or patterns, not using our inductive reasoning. And in using variables, we will be able to show that it is true for all cases, not just for the ones that we have checked. So there are some things that we need to know how to do. We need to show how we have an even number using variables. So even numbers are divisible by 2. Therefore, an even number can be 2 times anything. So 2 times 1, I get 2, like 2 times 2, I get 4, 2 times 3, I get 6. So if I take 2 times a number, I know I have an even number. So all of these numbers are divisible by 2 because 2 is a factor. So how I can show that for all numbers is that I can take 2 and multiply it by any number. So it doesn't matter what the number is. If I take 2 times that number, I will be able to get an even number. So this will be an even number. And you are going to want to put that onto your formula page. So even numbers are 2 times any other number. So x means any other number here. So how do I write an odd number then? So I have some odd numbers. So I have like 1, 3, 5. Those are all odd numbers. And basically, they're kind of in between all these evens. So here would be an odd number. Here's another odd number. And then here's another odd number. And how I can get from, say, this even number, this 2, to the 3 is taking my 2 and adding 1. So if I take an even number, I add 1 to it, I'm going to have an odd number. So it's like even, odd, even, odd. So if I take my even number, my 2x, and I add 1 to it, I'm going to get an odd number. So how I would get a 1, 2 times 0 plus 1 is going to be 1. How I get 3, 2 times 1 is 2 plus 1 is 3. Okay, so this is how I can show that I have an odd number. So even numbers are 2x, odd numbers are, here's an even number, and then I just add 1 to it, and voila, it's odd. So there is space for both of these on your formula sheet. Make sure you get them in there. Important. That's how I write an even number and how I write an odd number. Okay, so proving that the sum of two odd numbers and an even number is going to be an even number. Let's start. So I want sum, so adding. I want to add an odd number, another odd number, and an even number together and and see if I can get an even number. So how I write an odd number, I can do 2x plus 1, or it can be any number. Okay, so 2, So how I write an odd number, it's going to be 2 times any number. Let's say a plus 1. And I'm going to add that to another odd number. So another odd number will just be 2 times any other number. So let's say b plus 1. And an even number. So I can write an even number as just being 2 times any other number. So let's say c. Okay. And I'm going to see if I can figure out if this is going to be even or not. Okay, so let's just take a look here, get rid of some of these brackets. So this is basically 2a plus 1 plus 2b plus 1 plus 2c. Okay, I'm just going to rearrange some of these things here and add some like terms. Okay, so I have 2a plus 2b plus 2c, and then 1 plus 1 right there is 2. Okay, so I have 2a plus 2b plus 2c plus 2. What I get next. Now, I want to be able to write this as an even number. I want to prove that I get an even number every time. And an even number is just 2 times anything, right? So if I take a look here, I can have a factor of 2 that I can take out of each of these things, of each of these terms. Okay, so I can take a 2 out of 2a. So there's a greatest common factor here of 2. So I can take a 2 out of 2a, and I just get an a. Here, if I take a 2 out of this one, so remove that, so divide by 2, I get a b and a c. And then 2 divided by 2 is just going to be a 1. If I were to expand that back in, I'd get 2a plus 2b plus 2c plus 2. Yep, okay, that works out. That's good. And now I have this written as 2 times something. So 2 times any number is going to give me an even number. So it doesn't matter what this is, what this mess is. I have 2 times something. So I know that this number is going to be even. Yay! Last example is going to make use of this transitive property that we have. So we're going to prove that when 2 straight lines intersect, the vertically opposite angles are equal. So here are, we have to remember what vertically opposite angles are first. So you might remember from last year, vertically opposite angles are 2 angles that are opposite each other at a vertex. So here is the vertex of this angle, and directly opposite that is the vertex of this angle, vertically opposite. We want to prove that these 2 angles are going to be equal. Well, I'm going to label these. So we're going to label this angle A, here's angle B, here's angle C, and what the heck, here's angle D. Okay, so I want to show that either angle A equals angle C or angle B equals angle D. So that's what I want to end up at. Now, in order to do this, I need some more definition. So there are a couple things that I do know. I know that any 2 angles that are on a line, so like B and C or A and D, or A and B, or D and C. So if I'm looking at this line right here, I'm looking at these 2 angles, I know that the angle of a straight line is 180 degrees. Okay, so I know that B plus C is going to equal 180 degrees. I also know that these 2 angles are on a straight line. So I have A and B on a straight line. So I know that A plus B is also going to equal 180 degrees. Now I'm going to rearrange one of these equations to solve for B. So I want something that has to do with, I've decided to do A and C. I'm going to prove that angle A equals angle C. So I'm going to take this happy little B here, and I'm going to solve for it. Okay, so if b plus c is 180, I can rearrange this equation by just getting c out here. So subtract c from this side, subtract c from the other side. What I do to one side, I have to do to the other to maintain this equality. So c minus c, that's gone. And I get b equals 180 degrees minus c. And what I'm going to do now is take this b. So I know that b equals 180 minus c. I also know that a plus b equals 180. I'm going to take this b and substitute it into here. So I know that b is 180 minus c. So a plus, and substituting 180 minus c in here equals 100. Okay, now let's just get rid of these brackets. So there's nothing out in front to multiply, so I can just get rid of them. No expansion necessary. So a plus, then 180 minus c equals 180. And now let's get all of our, let's solve for a here. So I'm going to solve for a. Okay, so I want everything else off this side. So I'm going to get rid of this 180. So I'm going to subtract 180 from this side, subtract 180 from this side, 180 minus 180, it is gone. And oh, hey, 180 minus 180 here, also 0. Okay, so right now I have a minus c equals 0. Okay, and lastly, solving for a, I want to add c. What I do to one side, I have to do to the other to maintain that equality. So negative c plus c is 0. It is nothing. And I am left with a equals c. Oh, hey, there we go. Lovely. So I see that angle A equals angle C. I have proven that vertically opposite angles are going to be equal. So your guys' assignment is page 31. Numbers 4, 5, 8, and 16 you have to do, and then you're going to choose one question to complete from this set of questions. So 1 to 3, 6, 7, and 10. So an extension is to do more or all of these questions instead of just one, just to be comfortable and get used to it. So if you have time left over, make sure you're doing more practice. Okay, but you do have to do these 4 questions and then one from here minimum. Okay, so one last thing that you need to know before you start your assignment is how to write consecutive integers. So consecutive integers, we've already talked about, is like one integer after another. So like, 1, 2, 3, or 5, 6, 7, 241, 242, 243. So if my first number is like, can be any number, so x, okay, my next consecutive integer would be like x plus 1, so just one more. So like if x was 3, how I get to 4 is I just add 1. How I get to my next consecutive integer is just I add 2 to whatever x was, right? And then so on and so forth. So the next consecutive integer I could write as x plus 3, the next one x plus 4, so and so on and so forth. Okay, so those are consecutive integers. All right, you should be good to go.